Geometry. Welcome to section 5 of chapter 5. We're over halfway through the chapter, so good work. Keep it up. Keep pursuing the goal of getting this done and working for it and doing the best that you can. We have another triangle congruence theorem here, the SSS. Okay, sounds like a Navy ship or something like that. But SSS is going to stand for side, if I spell it right, side, side. Okay, SSS, side, side, side. And that's going to be if you have a triangle, two triangles have congruent corresponding sides, then the triangles are the same shape and same size, called congruence. Okay, so that's what the side, side, side is going to be. This is on page we're going to page 145. Okay, and here in the theorem, this is the side, side, side congruence theorem. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Okay, so here's your triangle. This is what it looks like, marking the sides that are the same shape. Okay, so if I have a triangle here, I have two green and a yellow. So if I make another triangle, you know, I get the other green out. That's exactly the same size. Okay, two green and a yellow, then they have to be the same size, same shape. So side, side, side. There's no way I can take this and adjust it and move it and get a different shape out of that. So side, 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 same shape. So our example here, let's go A, B, C. I don't want that at right angle, so let's say that's 89 degrees. Oh, we don't know angle, sorry. We don't know angle, side, side, side. So let's call this 5 inches, and 12 inches, and 13 inches. Okay. So if I draw another triangle over here, we can call it X, Y, Z. I know this is 5 inches, 12 inches, and 13 inches. Based off the side, side, side congruence theorem, I know that triangle ABC, the first one doesn't matter the order in which you write it, has to be congruent to. Now we have to follow it. So A corresponds to Y, so triangle Y, ABC. B is between the 13 and 12 side, so between the 13 and 12 side is X, and then Z is going to be the third one. Okay, so that's the side, side, side congruence theorem. A spin-off of that is what's called the hypotenuse leg congruence theorem. And this only works when you have a right triangle. Okay, so this has to be a right triangle to be utilized. Has to be a right triangle, has to have one right angle. Okay, so that's where we get our vocab words back at the top. They're talking about the legs and the hypotenuse. And when you have a right triangle, here's my right angle. Okay, the legs form the right angle, and the hypotenuse, always a fun word, is the longest side or the slope, the side opposite the 90-degree angle. So the legs are going to form the right angle. The legs form the right angle. The hypotenuse is always going to be the longest side, and it is referred to as opposite the right angle. Longest side, and it's opposite the right angle. So if you have a right triangle, and you know the hypotenuses are congruent and the leg is congruent, then you know that the two triangles are going to be congruent. Okay, so let's draw something like this. And we're going to share a side. It'll be a right angle. We're going to make this an isosceles triangle, so let's say this is 10 feet and this is 10 feet here. So A, B, C, D. Okay, this would fit under the hypotenuse leg theorem. Okay, because we know AB is congruent to CB, Okay, that's given. We know BD is congruent to BD. That's the reflexive property. And we have a right angle. Angle BDC equals 90 degrees, and angle BDA equals 90 degrees. Okay, that's the definition of right angles and perpendicular lines there. So then we know triangle ABD, write your congruence theorem the right way. The triangle ABD, so we have to start now. ABD, so CBD, in that order. Okay, so those are the new theorems: side, 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 hypotenuse, leg. Remember, our first theorem was side, angle, side. So that one still can come into play, still something we can use. Okay, so let's look at the questions, type of questions you'll have here. Okay. So decide whether the congruence statement is true. Explain your reasoning. Explain your reasoning. So what we have, they're asking triangle ABC, going this way. ABC is congruent to triangle EDC. So that looks to be in the right order. A to B matches E to D. D to C matches B to C, and these two are the same right here. These look like they are reflections, rotations of each other around point C. So we would say yes, and the reason is you see the congruent sides. So the reason is the side, side, side congruence theorem. Okay, so they are congruent, side, side, side. Here are number 2, KGH. KGH. And then they're saying, is that congruent to HJK? HJK. Well, that appears to be going in the same direction as well. You see this line right here is shared. So we can assume that is the third side, and that is congruent to each of them. So we have one side, two sides. Let's go one side there, two sides there, third side there. Side, 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 congruence theorem. Okay. What these are shortcuts. When we started with polynomial congruence, we had 6 things we had to show, or 8 if it was a quadrilateral. All the sides were congruent, and all the angles were congruent. Now we just have to show the 3 sides are congruent. Okay, angle triangle UVW. So U to V to W. We're going that direction. U to V to W. The one side and the 3 sides. Triangle XYZ. XYZ. So you see how that's going a different direction here. That goes one side then 2 sides. This goes one side then 3 sides. So the congruence statement is not true. Let's correct it. For our explanation, let's correct it. So we would say triangle UVW is congruent to one side, 3 sides, so YXZ. Triangle YXZ. Okay. And finally, RST. RST, so RST, one side, 2 side, 3 side. Triangle RPQ. RPQ. RPQ, like that. One side, 2 side, 3 side. That looks to be in the right order. Yes, and side, side, side theorem. Congruence theorem. Okay, it would not have been right if they said RQP. Okay, because Q doesn't match up with S, but RPS, S matches up with P, we're okay then. Okay, where we're going into this next one, determine whether the figure is stable. Explain your reasonings. Okay, triangles are stable. And if you're thinking about building something, anything that has a stand, any sort of foundation, triangles are stable. Quadrilaterals are not. All right, so you have this object here. You have a 4-sided object. And they want to... I'll come back. I didn't leave you. They want to know if that is stable. But when I talk about 4-sided objects, if I build a frame that is a square, Okay, if I just have one point of fastener on either side, that is not a stable thing. If I stand on it, whoa, it could collapse like that. Okay, so those are not stable. Now if I take something and cross brace it and form these two triangles, even if it's not at an angle, now it's stable. Okay, I can't squish it as well. So is this figure stable? I would say yes, it is. And I'd say the two triangles cannot change shape. Okay, they're going to stay with that size. There's a couple other examples here that we've already kind of talked about. This is from the textbook, page 263. Is this stable? Well, we already saw this. When you have a square, it is not stable, because there are different shapes they can get with those four lengths. Okay, not stable. Okay, this one here, is that stable? Well, this one I would be inclined, I see the two triangles, I would be inclined to think that it would be. So let's play around, let's see if we can get something going here. I'm going to make this one longer. Let me zoom out a little bit. And then, okay, right now that's not, so let's put another piece across here like this. No, that doesn't seem to shake on me. Okay, so there's, again, you have triangles, that's going to be stable. Here we have, I made this one beforehand, we have a quadrilateral on the bottom, then a triangle on top. So here it is. And is that going to be stable? Do you think I can change that shape? Okay, the triangle up here, I can't change that, but down here, the quadrilateral, that can change shape. So this one would not be stable. So triangles are stable, quadrilaterals are not stable. Okay, from there, we're going to do one proof here together, and then have some examples, questions on that aren't in here. You'll need some graph paper with that. Okay, write a proof. We're going to read, they ask us to redraw them side by side with corresponding parts in the same position. What that means is I'm just going to draw my triangles. So here's triangle A, C, B. Corresponding parts in the same position. Here's triangle E, D, B. Okay, that's drawing them side by side. So our given is that the B is the midpoint of CD. So a lot of times I'll write down my diagram, and when they give me something, I think, what does that tell me? Well, if B is the midpoint, that tells me that this segment has to equal this segment. That's probably going to be one of our steps as we write this proof. AB is congruent to EB. We have that. C and D are right angles. We have that as well. So again, our first step is always the givens. So I'm going to say AB is congruent to EB. Angle C equals angle D, which equals 90 degrees. And B is the midpoint of CD. Those can be sometimes broken into 3 steps, but we're going to put them all in one right now. Okay, so the piece of information we know from that is that this side can be our second step. CB, segment CB, is congruent to segment DB. Okay, because if that's the midpoint, then those two sides are congruent. And since that was the midpoint, I'm just going to say definition of midpoint. Well, notice we have a triangle. They want us to prove that triangle ABC is congruent to triangle EBD. When they want us to prove a triangle congruence, we either have to use SAS now, side angle side, side side side, or a hypotenuse leg. So which one fits in this situation? Okay, we don't have side side side. We don't know if AC is congruent to ED yet. Side angle side, our included angle is this angle right here and here. We don't know if that is. So the only one left is hypotenuse, leg. It is a right triangle. The hypotenuses are congruent and the legs are congruent. So we are ready to prove that triangle ABC is congruent to triangle EBD. And we'll say hypotenuse, leg, congruence theorem. This next proof is kind of tedious, but kind of annoying. You have a bunch of congruent segments. They want us to prove that the two triangles are congruent, the big ones here. And kind of a little common sense they are. If these two add up to these two, then the sums would equal each other, and you're going to use, which one would you use to finalize this? Okay? Would you use side angle side, side side side, or hypotenuse leg? And since they only give us stuff with sides, this would be true by the side 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 theorem. Okay, the final set of questions. Use the given coordinates to determine whether triangle ABC is congruent to triangle DEF. Okay, so we're going to put our coordinates on here. Go ahead and pause and get that written down. A is -2, -2. 2, 3, 4, -2. A, B, C is 4, 1, 2, 3, 4, 5, 6. Okay, is that congruent to D being 5, 7? 1, 2, 3, 4, 5, 7. E being 5, 1. And F is 13, 1. 5, 6, 7, 8, 9, 10, 11, 12, 13, 1. Are they congruent? Well, it's nice that we have some horizontal and vertical segments, because that's easy to check. Okay, we know that we have a right triangle because these are horizontal and vertical lines. So along here, let's see if these two sides, we can use side angle side to prove this. A to B, that length is 1, 2, 3, 4, 5, 6. Okay, let's see over here. Looks like D to E is our shorter side. 1, 2, 3, 4, 5, 6. Okay, D to E equals 6. So that's 6 and that's 6. Going up, we have 1, 2, 3, 4, 5, 6, 7, 8. So I'd say BC equals 8. And 1, 2, 3, 4, 5, 6, 7, 8. And EF equals 8. Okay? So does A, B, C congruent to D, E, F? I would say yes. Side angle side theorem to prove that. Okay? I think this next one kind of gets off a little bit, maybe not so perfect triangles, we'll see. So A is 0, 0, B is 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, there's B, and 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's triangle ABC, at least we get one side here. Is that congruent to triangle DEF? D is 0, -1. Get a different color. E is 6, -6. 1, 2, 3, 4, 5, 6. 1, 4, 5, 6. There's E. F is 9, -1. 6, 7, 8, 9. Looks like they could be rotations a little bit of each other. Okay, so let's check the ones that are easiest to count first. AC, that is 1, 2, that's going to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's check DF. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9, so those are okay. 9 and 9. Okay, let's check the length of some of these others. Now I notice B, let's say C to B. Let's find that. So that, if I'm trying to find that length, I can use the distance formula. Or this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So BC would be the square root of 4 squared plus 6 squared. 4 squared plus 6 squared. Square root of that is about 7.2. Square root of 52, that's what it is. Okay, so that looks like maybe this side over here. This is 1, 2, 3. So that's 3 over. That doesn't match the 4, so that would be different. Let's go from the other side. 1, 2, 3, 4, 5, 6. That's 6 over. So E to F, if we follow this, B to C, remember B to C should be the same length as E to F, because those are the corresponding parts in the congruence statement. So B to C should be the same as E to F. And we can see now E to F, 2, 3, 4, 5, that's 5. That's the square root of 3 squared plus 5 squared. So 9 plus 25, that's going to be the square root of 34. They are not equal. So they're not the same length. That makes them not congruent. Okay. So that's the side, hypotenuse, leg. We have side, angle, side. The next lesson is going to add the final 2 congruence theorems that we're using. Angle, side, angle, and angle, angle, side. So we get more angles in there next. So we'll see you in class.